And hello, everybody. My name is Nick Stewart. I'm a meteorologist that's certified by the American Meteorological Society. Today, we're going to be taking a look at the December 15th, 2021 tornado outbreak and derecho that moved across the Midwest. Truly a historic event in many, many regards. We're going to be looking at a lot of meteorology, a lot of radar data as well, but we'll break a lot of this down. If you're not a meteorologist, don't worry. We're going to make this nice and simple for you. A lot of really interesting information. Of course, I'm going to be taking a look at two things in particular that I think really set this event up to be exactly what it was and to unfold the way that it did. So let's take a look here. We're going to start things off with a look at just the historical nature of this. Yes, I'm using PowerPoint, but I promise we'll make this pretty interesting with a lot of maps going on. It is the largest tornado outbreak in Iowa history, with at least 61 tornadoes as of January 12th, 2022. That number could still go up as well. They continue to find more tracks using high-resolution satellite imagery. It's the only known derecho to have ever occurred in the month of December in the United States. That in itself is a pretty remarkable feat. Also, it will go down as the warmest day in the month of December in Iowa history, reaching all the way up to 75 degrees in a few different locations, and this absolutely demolished records for the date of December 15th across the board. Looking at the tornadoes, you can see tornadoes started off in eastern Nebraska, moved across western and northern Iowa into Minnesota, even all the way up into Wisconsin. This was a prolonged event which affected many, many states. Just looking at some of the impacts, there were 118 total severe thunderstorm warnings that were issued on this date, 71 tornado warnings. There were 55 reports of wind gusts of at least 75 miles per hour. That's the most for an event on record, according to the Storm Prediction Center. It overtook the August 10th, 2020 derecho, which was so devastating in Iowa, although I do think August 10th, 2020 probably had more total reports. But the problem is that power was out, stations were just destroyed. So I think the magnitude of the 2020 event likely limited just how many reports were actually coming out. Either way, 97 of Iowa's 99 counties were under a severe thunderstorm warning at some point, and by 9 p.m., more than 450,000 customers were in the dark, and this would continue to get worse as it moved northeastward through Wisconsin. But this was about the peak at one given point. Of course, this was a level 4 out of 5 risk by the Storm Prediction Center, a moderate risk that was upgraded that day. On day 3, was actually only a general thunderstorm risk. There mentioned no threat for severe weather. I personally thought this looked like a very classic severe weather event, and slowly but surely the Storm Prediction Center did ramp up their messaging, thankfully, just because I was kind of surprised at how limited information they put out at a time. Let's look at the water vapor imagery. This is using GO16, and what you're going to see is a really pronounced low pressure center really form here across portions of eastern Colorado, race across Kansas into Nebraska. A lot of dry air in the mid-levels, and then there is your eruption of thunderstorms along kind of like a pseudo dry line Pacific front kind of thing. We'll kind of loop this one more time. Again, you can really see the jet streak crank in here. Very dry air rapid at 500 millibar. Just a truly beautiful view on the water vapor imagery. Really, really quite stunning. Looking at the visible satellite imagery, this is one of the things that really led to the magnitude of this event. Because I want to show you, as the event unfolds, there's a few things to look at here. First and foremost, we'll stop it right about here. And what you'll notice is that here in eastern Colorado to southwestern Kansas, a full-on dust storm was raging, a haboob almost. Very strong winds, almost like a sting jet kicking in on the backside of this low. Really, really strong winds would be an issue for the entire upper Midwest, not even including the severe thunderstorm and tornado risk. But again, really, really high-end wind threat here. We'll continue to advance through the afternoon, and one thing you may notice is all of the sunshine here in eastern Nebraska, eastern Kansas, even sunshine across central and portions of western Iowa. A lot of sunshine was in place, and this led to a lot of instability to build in by the afternoon. This was a key point for this event that really led to the explosive nature of thunderstorms. Without this sunshine, this event would have likely been much, much different. We have these what are known as high cape, low shear, or low shear, high cape events. This was a high shear, moderate cape event, especially for the time of year, given the fact it was mid-December. Again, we'll continue to advance as you can see that line of thunderstorms. Obviously not discrete development. It was explosive thunderstorm along a boundary. We did not see discrete development, thank goodness, because that could have led to even stronger tornadoes across the states. Fewer tornadoes possibly, but potentially stronger tornadoes. All right, well, here is a radar loop. We'll let this play out. We're going to jump radar sites here, but you can see the big line of thunderstorms which raced across eastern Nebraska and then all the way across the state of Iowa, really at its peak here in the western part of Iowa, especially west of I-35. This is where it was really, really kicking. And then it continued to move eastward. Again, this whole line ended up being severe warned through the entire state of Iowa. The only counties that weren't under warnings were the far northwestern two counties up here, the only two counties that were not under a severe thunderstorm warning for this event. As we get towards late evening, 6, 7 o'clock, the line becomes less organized. Still very gusty. Wind gusts of 60 to 70 miles per hour were reported here, but you really lost the tornado threat, especially down south. We'll talk more about why the tornadoes occurred where they did here just in a little bit. But again, just a truly remarkable event. There were really two points at which tornadoes were occurring rapidly. It was very early on, around like 3:30 to 4 o'clock up here in eastern and northeastern Nebraska into northwestern Iowa, partly because the storms were moving southwest to northeast. And that line of activity was normal to the 0 to 3 kilometer shear vector. We'll talk about that more in a minute. But again, as that weekend, and we'll talk about why I think this weekend, before the next area began to surge here in western Iowa, and that would just race across central and northern Iowa. This area, again, was moving southwest to northeast, really tapping into the perfect environment for these QLCS, quasi-linear convective system tornadoes. All right, so let's talk about the upper level pattern. Here's the observations when you're looking at it from the upper level maps. 500 millibars, things to note, the 500 millibar heights go from 575 decameters to 543 decameters in only 12 hours. That is a rapid height fall. Also, the temperature drops from -11 to -18 in 12 hours. Of course, when you look at these rapid height falls, especially at 500 millibars, that correlates to a deepening surface area of low pressure, which obviously did occur. Also, a deepening lowering pressure that will then lead to stronger vertical wind shear. So through the profile, you're getting stronger wind shear. That's one thing that's also occurring. The other thing that's occurring with the temperature drop is that you're cooling here at the mid-levels, about 500 millibar. You're cooling that, and that will likely lead to then increased convective available potential energy, or CAPE, basically because as you raise the surface parcel from the surface following on the SQT, if you are cooling the mid-levels, you're then making that gap between the surface parcel and the temperature line, the observed temperature line, getting greater and greater there in the mid-levels, therefore increasing the CAPE values. And that's something that we really did see play out with this event. 500 millibar, obviously very key in any severe weather event, big thing in this event. So the impacts then here to the thermodynamics, again, we're talking about high-end values. Keep in mind, again, this is mid-December. When you're looking at the 0 to 3 kilometer CAPE here, you're looking at values of 175 to even up to 225 out in western Iowa, which is very, very high-end. When you're talking about these high 0 to 3 kilometer CAPE values, that favors vertical stretching of that spin or that vorticity at the surface. And yes, there was a lot of spin at the surface. All the blue contours here showing that. This is a product I really use a lot when storm chasing and forecasting tornadoes, is that surface vorticity and 0 to 3 kilometer CAPE. And when you have these things overlapping to the magnitude that they were, that screams problems. The other thing, too, when you look at the mid-level lapse rates, again, they were very high. again, for mid-December, your mid-level lapse rates were upwards of 7 to 8, even 9 degrees Celsius. That indicates, of course, higher instability in the atmosphere, and this was in part due to the rapid cooling at 500 millibar. Also, with a lot of warm air advection at the surface, creating a big temperature differential there. Looking at the overall 500 millibar pattern, this is looking across the entire country. What you got is strong divergence. I mean, these height lines are really just spreading out. And so when you have that strong divergence aloft, as that happens for continuity's sake, you need air to rise. And that's how you get a deepening area of low pressure at the surface. Also notice, of course, you have a negatively tilted trough here. The trough axis goes from the low to the south and east. That trough axis is negatively tilted. That favors strong warm air advection at the surface, as well as cold air advection aloft, therefore increasing the instability. Again, all these multi-level things just building on each other. And of course, you're also talking about a larger change in wind direction from the surface to the upper levels when you have these negatively tilted troughs here. So this was just a recipe for disaster, really all things considered. And now overlaying on top of this, the area of low pressure, the low pressure lines, you can see that area of low pressure there in like central portions of Nebraska, quickly deepening, which again is increasing that low level shear, increasing the shear across the whole profile. I mean, it was really just a quite a remarkable event. Here's closer up at 500 millibar. You can see this 120 knot jet streak wrapping around right at peak heating. This is happening right around 21Z. So for December, that's pretty much peak heating, right? As that's ejecting out, that's when you're really going to maximize a lot of the severe weather potential. So the jet streak is ejecting right at peak heating. That's a problem. You can obviously see the strong upper level divergence, mid to upper level divergence there supporting that surface cyclogenesis. And again, we're talking about that negatively tilted negatively tilted trough. So this was just truly a remarkable upper level 500 pattern. Looking again, when you look at the strong low level jet at 850 millibar, I mean, you're talking 50 to 60 knots across the whole, warm side of the system. The warm sector here, you have a huge plethora of 40 to 60 knots of winds. That's also allowing a tremendous amount of warm moisture advection across the state of Iowa. Notice the dew points here. This is one of the things that definitely could have changed the outcome of this event a little bit. The 850 millibar low was now closed at 21Z, but it was definitely lagging behind the 500 millibar and the surface lows in terms of strengthening. And so when you have a weaker 850 low here, for the severe weather setup, that's going to do two things. It's going to limit how much moisture can wrap up on the far northeastern side of the low. And you can see the dew points don't get that high that far north. About Sioux City is where things max out, and unsurprisingly, that's where the tornadoes begin to get more limited up here. And this begins to die down. And so the 850 millibar low likely prevented more tornadoes from occurring in southeastern South Dakota and to southwestern Minnesota. Because the 850 low was lagging a little bit, this prevented, one, the moisture from wrapping in. Also, two, it did prevent more, prevented less low-level shear from really occurring as well. When you look at the 0 to 500 meter storm relative helicity, the values max out right here and then don't really wrap around as you would sometimes see up into this case southeastern South Dakota. You don't really see that wrap around of that wind shear all the way around the surface low, and that's, I think, in part due to the way the 500 millibar low was a little bit slower to form. Here's a look at a sounding. A lot of the soundings that were launched on this day were kind of like an unfortunate timings. It was either just behind the storms, it was too early. This was probably the best looking sounding in terms of capturing the severe weather setup the best. This was at 18Z in Topeka, so at 12 noon Central Time. What you can see is high shear, modest cape. So looking at some of the things on this QT here, strong speed and directional shear. You look here at about 500 millibar, and you have kind of like a southwesterly jet here, 50, 60, 75 knots. And if you look at the surface, you have a southeasterly wind, as that surface low is really ramping in, also helping with the negatively tilted trough. You got southeast wind to the surface, southwest winds aloft. That's about a 90-degree crossover. That is high-end directional shear, and of course speed shear, 20 knots at the surface, but just above the ground at like 925 to 850 millibar, you're already over 50 knots. And then, yeah, obviously it kept going higher and higher as you went. But the other really impressive thing here was the instability. Obviously, you have high shear, but you have pretty modest cape for this time of year as well. Surface-based cape over 600, mixed layer cape approaching 500, and this number would only get higher, especially northeastward towards western Iowa. We talked about the lapse rates, again, the cooling of 500 millibar, likely favoring these strong low-level and mid-level lapse rates. In the low levels, you're talking, 5 to 6 degrees. The mid-level, you're talking 6 to 8 degrees. Very high-end mixed low-level lapse rates, mid-level lapse rates. And of course, your shear values calculated through with all the wind profiles here. Surface to 1 kilometer shear is 41 knots. You're looking for 40 knots at, effective shear, 0 to 6 kilometer shear. You're looking for 40 knots. You have 40 knots just in the lowest 1 kilometer. Very high end. And of course, the storm relative helicity values of 276, 0 to 1. Again, that's very, very high. So everything here just screamed problems. And that's part of the reason why we had a moderate risk issued across a good portion of the area. Now looking at some of the near surface shears, just looking at the plotted values, 0 to 1 storm relative helicity, well over 400 meters squared per second squared. That again is very high end in that lowest 1 kilometer. And you can see even here in south central Iowa, it's pushing 5 to 600. And when you look at this plot, this is when you look at the meta-analysis page, this is updated by Rich Thompson at the National Weather Service Storm Prediction Center, NOAA. They have these bar and whisker plots here talking about, significant tornadoes, EF2 or higher. And when you look at, the SRH of 0 to 1, the parameters they looked at, the events they looked at, you're capping out, the 90th percentile, somewhere near like 419. I mean, that was the base of this event, pushing well over 600 at times. So yes, the low level 0 to 1 storm relative helicity was off the charts. Generally speaking, you want about 100 just to favor tornadoes at 0 to 1. You're talking 4 to 6 times that. And again, that 0 to 1 kilometer shear was well over 40 knots across Iowa. The wind shear obviously was no problem. And we'll talk more about the directional nature of it, but it also really favored the QLCS, quasi-linear convective system tornado outbreak as well. Now looking at the very lowest levels, a great paper here by Coffer et al. It's using near-ground storm relative helicity and Supercell tornado forecasting. A great paper that really goes over some of the lapse rates that you can use for forecasting tornadoes, as well as the low-level wind shear. And one thing I really like about this paper is that it really starts highlighting that very low near-surface wind shear, 0 to 500 meters. And that is a critical thing in this event. When you look at the 0 to 500 meter SRH, I mean, it's well over 400 meters squared per second squared across the entire state of Iowa. Very, very favorable for that. And again, looking at one of the charts here on the paper, in this paper, I'll try to link it down to the video description below. Again, at the high end is 400. I mean, you're talking 400 the whole line as it moved through Iowa. So, I mean, this was, again, about as high end as you can get for wind shear. So, we talked a lot about the high end wind shear. Let's talk more about the direction of that wind shear, the shear vectors here. We're going to be looking at here, this is at 23Z. This is one of the counties here. I believe this is Greene County. I forget off the top of my head, Iowa. This is where you had like 3 to 5 tornadoes occurring simultaneously over an area of like 20 miles. The reason why things were very favored here is when you plot out the updraft downdraft convergence zone. This is a pretty well-known thing when forecasting tornadoes, including these QLCS events. This is something I look at a lot when I'm at the wall or just prior to severe weather moving into the area, a mesoanalysis. This is something that you really have to look at to forecast these QLCS tornadoes very well. The updraft downdraft convergence zone, best when you look at base velocity as well as base reflectivity, and you can kind of find that line there that kind of separates that. That is your convergence zone right there. And what I have plotted here in this yellow arrow, that is your shear vector at 0 to 3 kilometer, which tends to be regarded as the best thing for forecasting QLCS tornadoes. And that shear vector is normal to that convergence zone, or at 90 degrees. And that is the area where you will favor these QLCS tornadoes. There is a reason this particular line segment did what it did across the state of Iowa. It's because that area was, you can see aligned northwest to southeast, and that shear vector is southwest to northeast right across it. So that is why you had all these tornadoes form on that convergence zone. It was a textbook QLCS tornado event. And looking 2 hours earlier up towards the Sioux City metro, you got Sioux City kind of in this area right here. There's an EF2 tornado really, really close to Sioux City. Very similar thing. The shear vectors here were normal to that convergence zone on the reflectivity. And then the northwestern activity earlier in the day, this fizzled out and began to weaken more as it moved northeastern. I think, again, going back to that 850 millibar low, that 850 low was slower to respond. It didn't pull in as much moisture northeast and north of the surface low. Didn't pull in as much wind shear either because the 850 low was weaker. And I think that kind of suppressed the tornado activity in southwestern Minnesota into southeastern South Dakota. I think that really precluded a lot of potential tornado activity. All right, so I'm going to go full screen here, and I'm going to let me do the talking here. This is kind of looking at some of the radar data as this unfolded. I want to do a little bit of radar interpretation now using radar scope here. We got the archive data here from December 15th. We're going through 610. This is when we had 3 to about 7 different tornadoes on the ground at the exact same time as they really kind of buzzed through areas like Greene County, Boone County, that continued even northward into places like Webster County. Truly just a remarkable series of events kind of unfolded right here, especially starting approximately around 5:20. That's when things really start getting interesting. We'll kind of analyze this as we go forward, looking at the velocity data and of course the reflectivity data here. You can kind of see there are a few areas we're watching, kind of a little mini area here. This looks a little bit more interesting here. This looks a little interesting here. And then right here, there's a bunch of different shear zones. And one thing that really allowed this event to support as many tornadoes as it did is you're not talking about a single supercell, which has a very defined hook area. This was kind of a line of thunderstorms riding along in intense wind shear. And so along that, with a very sheared environment, you can kind of get these quasi-linear convective systems, or a bunch of these little basically small mesocyclones developing along the leading edge of a line. So we'll step forward here. This one clearly is moving up this way. That one may have fizzled. Looks like I got a new forming here. Maybe we'll kind of draw this line here. We'll drag this up. We'll keep going here. We can kind of see this continues. This one right here is definitely pretty impressive, as well as this guy right here. Stepping forward, and you can really see that within just a very short distance, we're talking about multiple likely tornadoes in progress. Again, we're looking at just the radar data here. We'll go into the survey data here in a minute. But again, just tracking these mesocyclones as they kind of move along, it's very easy. Looks like we have a new one kind of forming right here. That one kind of gets lost. But then also notice this one right here. Step forward. Yeah, this is obviously becoming a dominant one right here. This one continues to book around. This one continues here. Maybe getting another little circulation unfolding there. Another little circulation continuing here. We'll step forward again. Honestly, this one continues, this one continues, this one continues. And you can see what we're kind of watching here is within a distance of, oh, I did not mean to do that, but whatever. In a distance of 15 miles, you're looking clearly at multiple mesos unfolding here on this line. And again, this is kind of tearing through, this would be Greene County, Iowa, is kind of where this county is right now. So stepping forward, that one kind of continues. This one kind of weakens a little bit. This one kind of continues. This one continues. That one kind of continues as well. You know, these start kind of losing some shape up here, but this one really starts becoming more pronounced. This one also becoming really pronounced, heading towards Grand Junction. And again, it continues. This goes kind of up this way. This kind of goes up this way. This looks like just strong wind blowing towards Des Moines Metro, which is down this way. But then you kind of look like another circulation trying to form right there. Stepping forward, looks like that one continues. This kind of starts intensifying. This one begins to weaken. This one kind of continues. Maybe another one trying to form right here. And we'll just keep stepping through. And you can kind of really get the idea here of what's unfolding is that with the intense wind shear in place, you know, you're talking about all these little mesovortices forming along this line because of the really high-end wind shear. The likely reason why there were as many tornadoes as there were was simply because of the fact that you had a line of thunderstorms as opposed to a line of supercells, like a broken line of supercells. This is much more supportive of tornadoes, multiple tornadoes ongoing at the same time. Now, let's go ahead and also, I want to do something here. We're going to back up. Let's go to 5:30. We're going to put our marker right here. We're going to step forward to 6 o'clock. So just off the page, we'll say it'll be somewhere up there. So I'm going to mark it with my finger here, right here, up to here. In 30 minutes, the storm's traveled, you know, closing in on 40 miles. So you double that to get a mile per hour. You're talking 80 mile per hour. This line was basically moving at 80 miles per hour. And again, some of the more impressive radar frames, you know, right here is probably one of the most impressive ones. Clearly a circulation there, clearly a circulation there, and clearly a circulation here. No doubt about it. Maybe a one trying to form right there. I mean, there's no doubt that looking at this radar imagery, there are clearly 4 defined tornadoes. And what's also impressive, just looking at the reflectivity data, you can clearly see you got this hook right here, matches right there. You got this hook right here, clearly matches that right here. Some of this is kind of more wrapped in rain. There's, you know, something kind of floating around over there. But then, of course, you also have this little knot just trying to form right in the leading edge right there. And this thing just continued to book. So I want to turn on the correlation coefficient. We're going to let this load. All right, so stepping forward, we're going to back up, go back as this line is going through. You can see this big plume right here, likely some false returns going on there. Not too worried about that, but I want to step forward. We'll go forward a little bit here. And it's kind of noisy. There's kind of a lot going on here. But what you can kind of see is in this right here, it clearly matches this debris zone. You have a higher enhanced reflectivity with a reduction in correlation. That pretty much you can confirm is a debris signature. And then right in here, you kind of got some interesting shenanigans going on here as well. There's clearly a big drop up, but again, I think that might be more noise than anything. In this radar imagery right here appears to be the most pronounced debris drop. And you can kind of see it continues right here, just south of Jefferson. But you have this one forming right here as well, right on that other area that we were watching. We'll step forward. That continues. That continues. And then this debris ball continues. This debris ball continues. That continued right through Grand Junction. And then right here, you kind of got 2 little balls trying to form right here. This is north of Jefferson. And, you know, at this point, you know, there are so many tornadoes unfolding at an even point. Then things start getting a little bit more messy. The data kind of gets a little ugly here. Maybe still watching this debris drop right there, but it's really difficult at this point to see exactly what's happening. But the correlation coefficient definitely did help in some regards, although it was pretty muddled. I want to do a little bit of radar and recorded that one just a little bit ago, just to make it easier. But again, looking at the tornado surveys, I mean, you can just see where we're talking. Jefferson here, Grand Junction's right about here. And all these lines are EF2 tornadoes. And so again, I mean, these are strong tornadoes. These are higher end EF2 tornadoes just ripping through. And you can just see the number of them across this whole zone. And again, notice their movement southwest to northeast. That again is kind of what you would expect when you're talking about tornadoes, QLCS tornadoes, with that 0 to 3 kilometer shear vector going southwest to northeast. And again, you had that line that was kind of oriented northwest to southeast. Going right across was that shear vector, and that's what favored the tornadoes that unfolded there. So just truly, again, just a really, really impressive feat. Yeah, we'll kind of skip that. Anyway, so I think that kind of summarizes things pretty well in terms of what we were looking at for this event. Try to get this to about 30 minutes, so a little over. But biggest takeaway, again, is that 850 millibar low, it was a little bit slower to form, and that potentially precluded even more tornadoes from forming into southwestern Minnesota, southeastern South Dakota, again, due to a little bit more limited moisture in the mid-levels, as well as limiting the low-level shear a bit more on the far northern and northwestern edge of that surface low. I think the slower 850 low helped preclude tornadoes just a little bit. Also helped preclude discrete development. That likely could have helped prevent storms from really breaking away from the line. Obviously, it was a QLCS outbreak. Many simultaneous tornadoes in progress at the same time, again with those line segments normal to that 0 to 3 kilometer shear vector. And the other thing was, of course, that early days sunshine, that mixed layer cape of 500 to 1,000 joules per kilogram. That was a recipe for tornadoes with that low-level shear in place. Just everything really, really favored the tornadoes that occurred that day. If you do have any questions, feel free to let me know in the comments down below. I'll try to answer those if you do have them. Otherwise, this was kind of a look at the December 15th, 2021 severe weather outbreak. If you enjoy me doing these, I'm always happy to do more. Obviously, I cover them on the TV side of things. I will link that up here or something where you can watch my coverage during this. We didn't get quite the amount of tornadoes that central Iowa did, but we did have a few tornado warnings that day. So we were definitely trying to help keep people safe from those tornadoes as well. But hopefully you enjoyed this video. Like this video if you liked it. Subscribe for more videos. I've got a whole lot of stuff coming, weather videos, news videos, space videos, all sorts of exciting stuff. Thanks again for watching, everybody, and we will see you again at the next video.